Okay, so we just finished up a video in one dimension. Now we're going to start talking about distance and midpoint in two dimensions. Okay, so it's going to be a little bit more extensive. You're going to have to take some notes because there are a couple things we have to memorize, such as midpoint formula. So if you have any 2 points, remember on a graph we labeled them x1, y1, and x2 and y2. And those points are broken into an ordered pair. Okay, so we take our two x values, and you did see this on the midpoint slide on the last video. Take the two x's, average them, take the two y's, average them, and that gives you your midpoint. Distance formula is a little more extensive. It's got a big square root, x2 minus x1, and then you square it, y2 minus y1, then you square it. So take a minute, write that down. Go ahead, pause it if you need more time. So, example 4. We jumped around a bit. Find the midpoint and distance. So I already went ahead and labeled the 2 points, and I've separated where I'm going to work on midpoint and distance. So midpoint, regardless of midpoint or distance, you're labeling these x1, y1, and x2, y2. Remember, x and y go together. X and y go together. It should never be the two x's next to each other. That does happen a lot where we make a silly mistake and do that. Alright, so for midpoint, we're going to take negative 3 plus 2, divide by 2, comma. Now we're going to take our two y values, 4 plus 1, divide by 2. Now negative 3 plus 2 is negative 1, so my x value is negative 1/2. My y value, 4 plus 1 is 5, over 2. That's 5/2, which is 2.5. So if we go to negative 1/2 into 2.5, here's where our midpoint is. We're going to label the midpoint M. Typically, that's what you'll see as the midpoint M because, well, it starts with M. Alright, so for distance formula, make our nice long square root. And then we're going to do x2 minus x1. So 2 minus negative 3 squared plus y2 minus y1. And then we're going to follow our order of operations. We're going to go piece by piece, and I think the more you break this apart into little steps, the better it's going to be, and the less likely you are to make a mistake. Okay, so 2 minus negative 3, well, that's 5, so 5 squared, plus 1 minus 4 is negative 3 squared. Now, I have the negative in parentheses. Negative 3 squared is different than negative with a 3 squared. Okay, make sure when you have a negative sign here, and I'll put the 5 in parentheses just so we get in the habit of putting everything in parentheses, it makes a big difference. And a lot of times we lose silly points on quizzes and tests because we're making those mistakes. Square both of them, you get 25 and 9. 25 plus 9 is going to get you 34. If you try taking the square root of 34, you're going to get a decimal. I want to leave it like this. Square root of 34 is the distance. Midpoint's down here. Okay, now let's take it without a picture. Find the midpoint and distance of a segment with these endpoints. I'm going to label them again. Couldn't hurt to label just to make sure you're plugging in the proper things. Okay, for midpoint, x1 plus x2 over 2, y1 plus y2 over 2. 2 plus 8 is 10, and 10 divided by 2 gets us a 5. Negative 3 plus negative 4 is negative 7 over 2. I'm going to leave it as a fraction. If you wrote it as negative 3.5, you are right. Just different formats. Now, for distance formula, we want to take x2 minus x1, and I'm going to underline these as we go so you can help follow along, plus y2, that a double underline, minus y1. So, again, go step by step. 8 minus 2, that gets us 6. Negative 4 minus a negative, remember minus a negative changes that to a plus. So we've got negative 1 squared. 6 squared is 36. Negative 1 squared is 1. We're going to get the square root of 37. So we've got a midpoint at 5, negative 3.5, or 5, negative 7 halves. And then we have a distance of square root of 37.